Welcome in this screencast about M4R robotics, in which we look to the angles of the robot arms given the end position of the robot. So let's start with a robot arm. First arm over here. I say first robot arm over here. So we have a theta 1 and a length alpha 1. So the second robot arm is something like there, with a length of alpha 2 endpoint, and interesting to see when we make the angle over here, this is the theta 2. Well, the theta 2 is known from the previous screencast. So what we're looking for is theta 1 equals, and we have to find out what it is. So given the points A, B and C, what we know is that the position of point C, XC, and here we have the YC, we can use them to calculate this angle, a line from A to C, and we have the angle with the horizontal here, we call that a theta 3. We could easily say that the tangent of theta 3 equals, well, y of c and then the x of c. So in the end, theta 3 would be something like arc tangent yc divided by xc. Okay, found that one. Next step could be that we find this angle, the small angle over there, because if we know that one, we could say that the theta 1 equals theta 3 minus the small dot angle, and we can call the dot angle theta 4. So better theta 4. Okay, that would be nice. Okay, how can we do that? So we need another line. Say if we put a perpendicular line over here, so call this point E, we have a new rectangular triangle. Let's take that one out. I always do that, so I have a more detailed view of the situation. Robot arm 2, robot arm 1 over here. The angles, I know this is a theta 2, which is known, and here is the theta 4. We should like to know. Okay, so we know something more. Yes, this is the length alpha 1, sorry, alpha 2. This is the length alpha 1 over here, and of course we know this length because by using Pythagoras, this would be something like xc squared added by yc squared. Okay, well, have a look. So how about this red side? Could we determine that? Okay, so this side will be something like alpha 2 times the sine of theta 2, which is known. This part over here, maybe in yellow, this part over here would be something like alpha 2 times cosine theta 2. Keep in mind that we are interested in the theta 4. How big is the theta 4? So we could say the tangent of theta 4, so the tangent is the CE divided by the A, B, E and C divided by the AE. But the AE consists of AB added by BE, but we know that the CE is alpha 2 sinus theta 2, and the AB is just nothing else than the length of the first robot arm, and we just calculated the BE, which is alpha 2 times cosinus theta 2. Okay. So this is the tangent theta 4. So if we want to know the theta 4, it would be arc tangent, and we put this whole bunch inside here. Okay, so now we have found that the theta 3 is the big angle over here. We know the small angle there, so we could calculate theta 1 now. So the theta 1, the first angle of the robot arm, equals then arc tangent IC divided by XC, which is the big angle, minus the small one over there, which is arc tangent, and then you have the alpha 2 sinus theta 2. So you should know the theta 2, and here is alpha 1 added by alpha 2 cosine theta 2. So in order to calculate the theta 1, you should know the theta 2 first, and that's what we did in the previous screencast. Okay, thanks for watching.